Hello everyone, welcome to TechSmartStudy.com. Today we will study about law of reciprocal deflections or Maxwell's reciprocal deflection theorem. Before going through the definition, let's understand work done by a force on a member. Let's take two cases. Case 1, let's take a beam AB, a load W applied gradually at point C, due to which deflection del is occurred, for which the work done by the force W is equal to half W into del. So we have taken del because del is occurred at the line of action of load W. That's why we have taken the work done. So the work done by the force W is equal to half W into del. So we have taken W and del because here the deflection is occurred at the line of action of load W and due to line of action of W. That's why the work done by the force is equal to half W into del. And let's see case 2. Let's consider another beam AB which shows a member carrying a load K. This load, by virtue of its own direct action, will produce a deflection. Let us for a moment consider the load K as a very small load. Hence, the deflection produced by K is also very small and the work done by K may be ignored. Suppose now, due to the action of some other external agency, the member is subjected to a deformation. Let Y be the deflection in the line of action of load K. Now, so let's explain it. What it says that a load K is applied on a beam AB. As the load is very small, the deflection produced by the load K will also be very small, so it can be ignored. So at point C, another external agency is applied. So due to this external agency, a deflection Y is occurred at line of action of load K. So here the work done by the load K due to the above deformation is equal to KY, because Y is occurred due to the external agency load, and this deflection Y is taken place at the line of action of K. That's why the work done by K here is K into Y. Let's understand these principles by example. AB is a beam, load W is acted at point C and an external agency X is acted at point D. Due to load W, a deflection del is produced, and due to external agency, capital deflection is again produced. The work done by force W at C is equal to half W into small del, because this small del deflection is directly occurred by the load W and it is acted in the line of action of load W. That is why the work done by force W at point C is equal to half W into deflection. Work done by force X, that is the external agency. So due to the external agency X, capital deflection is occurred. The work done by force X at point C is equal to W into capital del. That is because, as we understood in case 2, that when the deflection is occurred at some other point due to an external agency at any other point, the work done will be equal to the force that is there in the line of action into the deflection. So that is why the work done by force X at point C is equal to W into capital del, as it is present in the line of action of load W. The work done by external agency X in its line of action at point D is equal to half X into capital del, because this capital del is caused directly due to the external agency X. So that is why the work done is half into X into capital del. So now the total work done is equal to half into W into small del plus W into capital del plus half into X into capital del. So now let's understand the Maxwell's reciprocal theorem. In any beam or truss, the deflection at any point D due to a load W at any other point C is the same as the deflection at C due to the same load W applied at D. Let's take a beam AB and consider it as figure 1. So here in beam AB, W is an load which is acted at point C, for which capital del C deflection is occurred at C and capital del D deflection is occurred at point D. And in figure 2, another beam is taken and here the load is acted at point D, for which a small del D deflection is caused at point D and small del C deflection is caused at point C. And what Maxwell's reciprocal theorem states is capital del D is equal to small del C. This deflection is equal to this deflection. So let's go through The definition: in any beam or truss, the deflection at any point D due to a load W at any other point C is the same as the deflection at C due to the same load W applied at D, which meant the deflection at point D due to any other point W at point C is same as the deflection at point C due to any other load at point D. So let's prove. In figure 1, the work done is half into W into capital Del C. So here the work done by the load W is half into W into capital Del C. In figure 1, let another equal load W be applied at D, and for this load at point D, additional deflection is caused. Small del C deflection at point C and small d deflection at point D. Let's take this figure as 1.1. So the work done is equal to half into W into capital Del C plus half into W into small del D plus W into small del C. Let's take this equation as equation 1. Similarly, in figure 2, the work done is half W small del D. Another equal load W is applied at C, and for this load W, additional deflection capital Del C is occurred at point C and capital Del D is occurred at point D. And let's take it as figure 2.1. So the total work done at this stage is equal to half W small del D plus half W capital Del C plus W capital Del D. Let's take this equation as equation 2. And as the load is equal and the beam is equal, the work done in both cases is equal. So equating both the equations, we get small del C is equal to capital Del D, which is the Maxwell's reciprocal theorem. Hence